Hi, my name is Valeria Legaria, and I'm going to be sharing with you a little bit about our final evidence for this class. Well, so first of all, we created a database in Excel using 5 stocks as our dependent variables and using many others as our independent ones. Then these we made it because we wanted to estimate and calculate the return that each stock was gonna have. So we started off downloading all the packages and libraries that we were gonna be using for this exercise, and that's what we did in the first part, as we can see here. Then we created, based on the database, we divided each stock um, like in the sheets. So our studio like could understand which variables we were taking. So our first variable was the stock using JP Morgan. And well, the here are the pages that were given by the program. Then the first part was the regression. We made these, and these were our variables, our independent ones: the confidence consumer, the Fed funds target, inflation, initial jobless claims, no farm payrolls, the manufacturing PMI, durable goods, the index, and well, our dependent one, we use banks for this exercise to see which one had the best return. So well, I'm gonna be explaining the first stock, and we did the same with the other 4 ones. So now that we run the regression, we calculated everything related with the medium, the average, and all the stuff like that, just to have a more clear view of what we were doing. We also run a correlation and table, and we plot it with ggplot. And well, it's a lot of information in here, but when you open it right away from our studio, we can see it clearly. And here is just showing the relation that our independent variables had with our dependent one. Now, well, we made also a comparative between the estimated and the real values. And this is the result also on a diagram. Well, this one is the coefficients one using the lasso stuff. And here we have also a diagram to visualize it better. Now we try running alternative regressions just to see like a better option of this. And well, this is the code. And finally, we ended up having this graph showing with the regularization stuff. And well, yeah, it's kind of correlative. So we also here plot the error estimation for this exercise. And we also try to get better with the lambda result. And well, that's what we run. And then we run our rich final coefficient model. And this is how it ended up. Now, well, we also made many changes on the lambda variable just to see how it was doing. And this was the other graph that we had, which the first one like looked better, but well, it was just trying to see which one ended up with the best result. So, well, we did the same thing just to make sure that point. Now we made the analysis of the regression. Here we have 359 samples with 11 predictions. And well, we have here our R square, the mean square error, and well, these just to know what that the information that we were calculating was okay. And we started with the support vector machine analysis here. We made many models to see which one ended up being the best, like always. We also calculated the target test predictions. We divided our library into training and test, so it could take like the most of it in a better way here. And then we plotted finally just to see the cross validation. And now we're going to transform the our dependent variable column into qualitative variables. And well, here is just again the information just to make sure we are getting it straight away correct. And we again calculated the median, mean, and we made it everything numerical, and the column that needed to be a factor, we also made it just, well, for purposes of this exercise. Then the third part of this code was using the decision tree analysis. So we divided the in 80% into a training part and 20 into the test one. Here we're running it, and this was our first decision tree, as we can see. This one is in a very like simplified way, but when we run everything here with the adjusted curve and also the real size of the tree, we're gonna be ended up with a huge result. As we can see here, all our variables. It's a lot of information. We ended up with a huge decision tree, which this model is not the best one for this exercise because we have a lot of information, a lot of correlation, and the diagram is just going to be so huge that we're not going to have the opportunity to understand it in a visual way as we would like it to be. That's why, well, we just did to see how it was going to be ended up. But well, this is part of all of our variables. But now we're gonna go with one of the best programs and models that we saw, which was the random forest stuff. Okay, here. So we download the library that was that we were gonna be using. Also, these libraries that we're gonna be using to make a diagram in a visual way. So we create data partitions again to have this information like taking many data. We made our random forest, the regression random forest. This was our result. Here we have it in a clear way, like the relation of our independent variables with our dependent one. And here we can see the adjusted curve, which is kind of similar to the one of the decision tree analysis. But this one, this analysis, the random forest one, it's way better because we can see clearly and it gives us like the best results. So this was everything that we estimated with random forest. And well, we also made these curves to adjust the models. And well, here we go again, making the same process, but now with the second stock. And that's like in every stock. So just to conclude on the results of the code and all the models that we were using, my personal opinion is that the best way to calculate and estimate something, it's using, if we have like simple data, it's easier just using regression. But if we have more complex data that we want to analyze, because we want to analyze the feeling of the market, also like the movement on the stocks, it's way better to use a more complex program. In this case, decision trees or random forest. For this exercise, random forest was way better because decision trees, we go again to the same thing, that it's a lot of information. So random forest ended up being our best model. And well, yeah, that's all. Thank you for your attention, and bye.